Alrighty, are we ready? Are we live? Can everyone hear me? Once I go full screen, I won't be able to see the chat until we go into questions. So please give me a sign you can hear me. All good? Yep, you can hear me? Okay, cool. Cool, thanks, Francesca. Okay, I'll start then. All right, and we can save any comments to at the end. Okay, so let's take my headphones off. Good afternoon, good evening. Hello, everyone. How's it going? My name's Tim Oliver. I'm a software engineer for iOS at a company called Drivemode. This is going to be a very interesting talk for me. This is the first time I've done this kind of format. This is all new to me. This is kind of very interesting. And what I want to talk about today is kind of like a journey I've spent this year. I've really spent a lot of this year actually jumping into SwiftUI for the first time. So I thought I'd talk about what I've learned this year, what I fall back on, basically how I actually came to a good balance between UIKit and SwiftUI and some of the projects I'm doing this year. So without further ado, let's jump in right away. So a little bit about me first. Who is this guy? If the accent isn't obvious, I'm from Australia. I normally live in Japan. Drivemode is actually a Japanese company, but at the moment, because of the pandemic, I got stuck in Australia. So I'm enjoying the lovely winter in Australia still, but I'm about to head back to Japan. But I think we can all agree it's been a very, very interesting year in that regard. I've been a fan of iOS development ever since the iPhone 3G. I'm not sure how many other people in the chat have owned or seen a 3G before. That was the peak of 2008. But even back then, the second generation iPhone, it was very obvious where this was heading. Like it was a mini computer that you had on you at all times with internet access. Like the potential even back then was huge. And I've been loving every second of it ever since, even though it's been over a decade at this point. Originally, I was a web developer. So my degree at university was called digital media, which meant I did both computer science and multimedia, which actually came in real good handy because it meant I did like front-end development, CSS, graphics design, but also back-end like database design. And these are all great things that actually blend together and ported very easily from web development over to iOS development because, let's be honest, it's more or less the same thing. And since 2013, I've actually been doing full-time iOS development. I've worked for a few companies at this point, but my two main ones I worked at was Realm. I'm sure most people have heard of Realm. Realm's an embedded database that runs on iOS and Android and was acquired by MongoDB after I left. And more recently, I worked at a company called Mercari, which is basically like Japanese Craigslist. And now I currently work at Drivemode. And Drivemode's a small American startup that's stationed in Silicon Valley and in Japan. And we build iOS and Android apps to help try and make the driving experience a lot nicer by adding modern integrations like GPS and music and callbacks and things like that. When I'm not doing iOS development for money, I'm doing it for the love of doing it. I love publishing open source libraries. If anyone's considering getting into it, I really, really recommend getting into the open source community. It's fantastic. We use open source software to deliver our own apps faster and with better reliability. And it's really good to give back when you can. And one thing that's really not obvious is open source libraries really let you think about how to solve software and become a better developer on your own. But another really good thing that people might not realize is it's actually a really good way for applying to jobs. Like the last 3 job applications I went to, I just sent them my GitHub account. That technically became my resume. So I would definitely recommend putting as much of your code as you can out on the internet in open source. And when I'm not programming, and those rare moments I'm not programming, I also love doing karaoke, hence Japan, and playing video games. Animal Crossing has been a fantastic game this year. It's where the great going outside simulator game of 2020. Just to back up a little bit, my main open source side project is I think called a ToCropViewController. You consider it to be a very basic sort of library. The idea is basically you can give it a UI image and you crop out a smaller region and exports it as another UI image. You'd think this is default functionality in iOS, but it's not. But as a result, it's been adopted by a few apps. Probably the biggest one is Google Drive. But it's definitely the one that I spend a lot of time updating and maintaining. But the reason I made this library was originally because I'm actually making a DRM-free comic book reader called iComics. The idea is you can read comic books that you buy or download from online. They're zip files with JPEGs in them, and the app itself decompresses zips and displays JPEGs. And you need a cropper sometimes because you might want to share a section or you actually want to do some editing of a specific comic book page. So I'm just doing as a bit of backup. Both of these are Objective-C, by the way. Just to give a bit of backup about where we came from, because this is going to lead on to where we went into this year. If you weren't around for the iPhone 3G days, this is what it looked like. This is a premium iPhone in 2008. Yes, the backside is plastic, but the front's still glass. That's the same. It was really hard to develop for these things. Like, they were really slow. We're talking a single core CPU running at about 410, 400 megahertz. So everything was slow in terms, like simple things like image decoding and the likes. The most painful part was it only had 128 megabytes of memory. Now, we're looking at iPads these days of 6 gigabytes of memory. Sometimes you don't even have to think about memory these days anymore. But back then, 128 megabytes was all you had, and they had to fit the OS in at the same time. And so it was very easy, even if like a single table view controller, just scrolling down, it was very easy to actually run out of run out of memory and start getting memory leaks, memory warnings happening constantly. So I really like the fact that we have a lot more memory these days, even though it's probably still best practice to worry about your memory, because that means you won't be evicted when you go to the background. But honestly, it's a lot better now than it was back then. Another thing that back then, there was no iPads, there was no tall iPhones, there was no Max iPhones. It was just a single screen size. And this is actually kind of hilarious, because a lot of people tried to cut corners in UI design by, instead of using Apple's native UI controls, they would actually just make a JPEG that was 320 by 480 of the UI, and then just have invisible tap zones on top of it. So I don't miss those days. I'm glad we now have resizable iPhones, because it kind of got away from that very static type of app development. Probably the biggest thing, and this stuck with me for the longest while, was the GPU was actually really slow, to the point where if you actually had many layers on screen at once, that was enough to cause that alone was enough to cause frame dropping. One really bright programmer called Lauren Richter coined a technique where, instead of having lots of layers, you should just use core graphics to have one view that then draws all the context into one particular view, and then put that on screen. Because actually doing that, even though that was more CPU utilization, that was actually less GPU utilization. So you could do this really hacky sort of like combination of techniques to get 60 frames. But again, we don't have to do that anymore, and we're so much better off for it. Another one was no Grand Central Dispatch. NS operations were a thing, and they were subclass from NS threads. But if you want to do any sort of really trivial background operations, it was still a lot of effort to manually set up NS operations and go through it. That came out on iOS 4, and it was really good when that came out. The most painful thing of this is if you have never touched Objective-C before. There was a thing back in the old days where there was no garbage collection, but you still had to manage your own memory. There was this thing called reference counting, where you actually had to like track how many references an object had on your own. And if you screwed it up in any way, it would just crash the app. And there were debugging tools, but it was still so much pain to have to work out exactly where you accidentally released something too early or held on to something for too long. And it was, some language called Objective-C. Like Swift came out in 2014. It's still actually as far as languages go, it's still a very new language. It's still so much is to come still. But one great thing I can basically say from all of this is, if you're coming into iOS development now, you've picked a great time to come in. It's never been a better time to start. Now that Swift is now entrenched and mature, and it's not so much as in flux as it was in the first few years, and now we have even better tools like SwiftUI. If you're coming in for the first time, this is the best time, I think, to start. That being said, giving you a kind of a background of where you came from, and why, and in a sense that where I've come from, in the sense I've been doing this for so long. Apple has this character called Krusty that they like to use in some of their developer talks. Krusty being the stereotypical engineer who's been around forever and he's still used to the old ways. Like one of my friends in Japan actually bought me like Krusty's hat so I could put Krusty's hat on, but I won't, because I'm going to not do that. In the sense that once you're stuck in your own ways, you kind of reject the new. You're like, no, Objective-C is the best language. Why would I ever want to use Swift and things like that? And so certainly, a lot of people can accuse me of that. I've been called an Objective-C dinosaur before. But basically what I want to say here is certainly there's a nice balance between sticking with the old and the reliable and the established, and certainly jumping ahead to the brand new shiny and the cutting edge. So you can say crusty, but I'd like to use the word pragmatic in this sense. And basically, when I say pragmatic, it's usually a lot of the time is sometimes you, just by sheer virtue of your circumstances, you can't jump on board the latest technology. I'll leave this quote up. You can read it while I'm talking about it. A really big example is a lot of the companies I've worked at. and a lot of the projects I support, they have such stringent back compatibility requirements. Like iComics is still iOS 9, and Realm is still iOS 8 or 9, even now today, to the point where when a new kind of technology comes out, when Apple announced SwiftUI last year, a lot of us were like, well, we can play with that, but to actually start using it in real shipping software and actually seeing how it actually performs in a shipping environment, it's the kind of thing that we can look at hopefully in the distance and kind of like really hope for it to when we can start using it for reals. That being said, best practice that Apple recommends, and this is actually a quote from one of the Apple engineers on the Apple developer forums, is you should always target the latest version that's out there and then one version behind that, because any version you support beyond that, that's when the maintenance costs and the trade-offs start to not be worth it. So in that regard, now that iOS 14 is out, and apparently according to Twitter, iOS 14 is now at least 40% penetration. We're already at the point where iOS 12 is probably well and truly out, and now we can actually start looking at SwiftUI for real. But yeah, just in that regards, what I was talking about is, you're staring at the distance, being like, that is such a shiny. If I try that now and I love it, I'm gonna be like pining for it this entire time. I'm working on this old code base. And yeah, to that extent. But this year, basically, I had the opportunity to try out 2 new projects. The first one is I'm going to start doing a rewrite of iComics. iComics at the moment is like the best Objective-C of 2010. Like, it was built for iOS 5. It's really old. It doesn't do size classes. It's all Objective-C. It was designed for an iPad with 250 megabytes of memory. So there is an argument that you shouldn't really ever rewrite an app. You should just sort of refactor it until it's a new app. But I think in this case, it just makes more sense to just scrap the whole thing and then restart in Swift with modern features and where we can go from. And the great thing is now that iOS 13 is now the back version, it's very, very straightforward to actually, we can actually start looking at SwiftUI. On the flip side, also, Drivemode, when I joined Drivemode was just about to start looking at a new app project. And so because it was a new project starting from now, the requirement was obviously we can start from 13, which meant that SwiftUI was also viable in that regard. So finally, after all this time, I was like, wow, I'm actually finally in a position, like professionally and in sort of the projects I want to do, that I can actually start, like, stop looking at UIKit and actually start looking at SwiftUI seriously. And so that's what I did this year. Just a lot of hacking, a lot of playing around and seeing what sticks and what didn't stick. It was basically just jump straight in and see how deep the hole goes. The hole is pretty deep, and basically seeing what I thought of it. The thing is, as it's obvious from my photocopying library, I'm very particular about having really fine control over my UI. So I was like, I don't know about this SwiftUI thing. I kind of really like having the pixel precision control. But the response was, wow, SwiftUI is amazing. Holy crap, it's so good. It is so good. Like, I didn't really realize this, but it made me not want to write UIKit code really quickly. Like, suddenly UIKit just seemed like so much effort compared to SwiftUI. Like, for example, writing a label on screen. Like in UIKit, that you have to instantiate a UI label, you have to give it a size, you have to give it some auto layout constraints, you have to give it a background color, a foreground color, a font, add it to the view hierarchy, and then if the view hierarchy changes, you've got to manage that. Compared to what in SwiftUI, just one line of code, which is text, and you can modify it if you want, but if you don't, it still has pretty much all that stuff automatically. And the thing that is really cool about SwiftUI is its semantic nature, like the fact that you're not really explicitly defining what is going to go on the screen. You're basically explaining to the renderer what you would like to see on the screen, and that's sufficiently decoupled to the point where you can, in theory, have one code base that then just changes shape depending on the platform you're on. There's a great sample app here called by Jordan Singer called SwiftUI that it's a set of code that shows you how every single SwiftUI control behaves on all of Apple's different platforms, from the watch up to the TV. And it's just absolutely incredible that you can do this with so little code, and doing this with UIKit would be so much effort because you'd be writing 4 or 5 different code paths, and the amount of code and time and effort you save is just absolutely incredible. Like, holy moly, this is good. So the old meme of like absolute unlimited power. Like, I got really excited at this. This is some really cool stuff. But again, maybe I should put the crusty hat back on. Maybe I'll put the crusty hat back on for this particular talk. Sorry. Yep. Well, I've got a lot of buddies on Twitter who've run into issues with SwiftUI. There's a lot of troubles. The fact that SwiftUI has got a lot of problems, even if SwiftUI is ostensibly itself can be quite limiting compared to UIKit, because it is still a very singular track sort of things you can do with it. That aside, the other problem is that it's quite buggy still. Even iOS 13 was one, but now even in iOS 14, there's still issues happening in Xcode 12. Big Sur is apparently still having a lot of issues. I think Peter Steinberg was saying even Apple's sample app, like you can crash it pretty easily if you do certain things. I'll take the crusty hat off again now, but just taking that with a grain of salt, as awesome as SwiftUI is, we still have this situation where it's so new and it's still potentially so brittle that we are in a sort of a weird sort of like love-hate relationship where it's like, I want to use it, but I might be shooting myself in the foot if for performance reasons or whatever by using it. So just to go back and think about it for a little bit, like it's really good. Like this is definitely the future. Like the amount of speed and quality we can put out apps with this thing means it cannot be ignored. Like everyone should be using SwiftUI or at least learning SwiftUI at this point. And it saves so much time and effort. Like even things that you don't even think about, like localization or specific languages that read right to left and left to right, like that's automatic. If you have accessibility concerns, like increasing the size of text on when the accessibility settings like that, that's all automatic. It's so easy to the point where you'd be crazy not to use it. But at the same time, if your app isn't just a list, if you actually do have more content, like in my case, like a page view controller, you might be limited by what you can actually do with it. And that's something to keep in mind, because certainly if you've got an app that is just lists, there's a lot of use cases are just lists. But if you have anything more than that, more dynamic than that, you should maybe consider doing something a bit differently. The problem is there are a lot of edge cases and a lot of issues. Like even things like one issue I saw was on macOS, it was responding to the safe area insets features of Big Sur, even though I was still running Catalina. But because Catalina did not support safe area insets on macOS, I could not disable it because the APIs weren't there. So there are those sorts of issues where just by sheer polish, certain things are not where they should be at this particular point in time. We are in a sort of a flux at this point where we might think, oh yeah, that's possible, and then actually build it and go, oh wait a minute, no, that's not possible actually. It's broken and there's nothing I can do to fix it. So something I was actually considering this year from looking at this was SwiftUI is so good that I don't want to go back to UIKit. You can't make me if you try. But at the same time, these problems, they will be mitigated eventually. This will go away eventually. But for now, basically, we need to try and think of a way to get around it for now. And I think this has been talked about on Twitter a fair bit, but this is something that I definitely agree in. By default, what we should do now is we should try and build our interfaces in SwiftUI first. And if it doesn't work out for whatever reason, we can then just drop back, not the whole app, but just drop back that particular part to UIKit. Now that's a loaded statement. It is possible, but by saying that, maybe everything doesn't work in SwiftUI and the whole thing has to go back to UIKit, but hopefully not. The idea is basically, if you can get away with doing it in SwiftUI, do it in SwiftUI. But if you really have to bite the bullet, you can go back to UIKit. So I definitely think for like an app like iComics, or iComics 2, basically, is what I'm working on. I really think like a really good app should be like the core user experience, the thing that really gives your app the value to the user. Like in my case, it would be the page turning view controller. That should probably be UIKit, because you can then tailor it exactly to how you want, and to provide the best quality for your users. But that kind of app has a lot of auxiliary view controllers, a lot of lists, a lot of buttons, a lot of palettes and panels, and those are just so annoying to write in UIKit. I definitely think the best of both worlds should be core logic in UIKit if you have to. If you don't have to, sure. But then everything around, you can just make that SwiftUI. And that way, you still get a really fast turnaround, but you do get a good amount of control at the same time. So just to go back on what we're actually doing at Drivemode at the moment, because we're starting this app from scratch with iOS 13 in mind, we basically decided, let's start with SwiftUI. So rule number one, SwiftUI, all the things. But then as we start to think about the design a bit more, we were thinking like, well, we actually kind of do have that kind of requirement that a lot of apps have, where you need to have dynamic routing. Like when the app starts up and has to do state restoration, and the user could have pushed any number of arbitrary view controllers, you sort of can hack that with navigation view in SwiftUI, but it certainly gets to the point where it's really, really messy, to the point where you'd be spending more time fighting SwiftUI than actually getting it working. So we basically came to that conclusion just by our requirements that we had to look at. And yeah, we could have forced it with SwiftUI, but basically we had hit this point where it's like, is this actually more effort than it's worth? And so we actually went back to the drawing board and said like, well, hang on. So we can definitely keep all our SwiftUI code. Like every single screen is a discrete view controller, and that's a discrete menu that is very easy to implement in SwiftUI. But all we have to do is control the navigation. So what we actually decided to end up doing in the end, basically it was me asking my coworkers like, can we do this? Because I don't think navigation view is going to work. And they were like, yep, that's fine. Is you can instead actually just host SwiftUI inside regular UIKit view controllers, and then use a regular UI navigation controller. So what would that look like exactly? I hope this is probably not too much complexity, but I'm just putting it here just to make sure that everyone knows this is possible. I basically tested this to make sure it's possible. I started to go about the way as maybe we should go back and just design the code in such a way that if you looked at it from the outside, it might look like a regular UIKit view. Like you can certainly, from the outside, implement all of SwiftUI away so it looks like it's a regular view controller. Like in this case, you can make a dedicated view, then have a dedicated subclass, which then actually wraps the creation of the view. And then as you can see, you can just create it like it's a regular view controller and then push it to a navigation controller, just like it's a regular normal UIKit view controller being pushed on a regular normal UI navigation controller. And that's really good because in this kind of thing, like still you want to worry about what your interfaces look like from the outside. A lot of the time is you still want to maintain, this is something you learn really quickly when you do open source software. You really want a really good looking public interface because that makes it so much easier to work with your code. And the first thing I was wondering about was like, well, if I do this, what do I actually lose? Like if I want to have like a title in my view controller at the top of the navigation controller, or if I want to make it large, can I do that? The answer is yes, actually it works. You do need to tweak it though. Like I think, I'm not sure if it was this one particular, but in some cases you do actually have to go back to the navigation controller itself and configure things like prefers large titles is on. Like you still have to configure it normally. But the cool thing is a lot of these SwiftUI commands do actually interface with regular UIKit. So you don't actually lose anything in this regard. That being said, I have seen some funniness. Like I did see like I think if you have a scroll view and a large title, sometimes the animation might look a little bit weird. So sometimes you might have to consider your UX and how you want to do it. Like for example, maybe you just can't use SwiftUI for large title view controllers. But there's certainly those sorts of little gotchas that you won't know about until you actually try it and see what kind of visual glitch you might end up with. But the next question is, then how do you actually push to a new view controller? Like if you go from that detail view controller to a profile view controller, how do you actually get access to that navigation controller? Because unlike UI view controller, you can't just get at the navigation controller context because that's not visible from the view layer. You could, I suppose, use protocols to abstract this away, or you could just implement it manually. You could inject the navigation controller property from UI hosting controller. You could do that, and that's not bad. But what I actually would actually argue is this is actually a really good thing because it actually does sort of encourage more good programming practices. Something that is talked about a lot these days is the fact that a view controller should not actually, in terms of good separation of concerns, a view controller should not really control what other view controller it goes to. And so what this has led to is there's actually some really good articles online. I think Sarush Kanlo has talked about the coordinator model. And if you look up Viper, the router is another one. The idea is there's an overarching object above all the view controllers that control the flow of the app. And so it's this one that actually makes the core business decisions about which view controller should be pushed from which view controller. And that just makes it a lot more decoupled. And in that case, by implementing something like a router model, which does actually fall back to sort of like the Redux sort of like state-driven paradigm of SwiftUI, this actually makes it really easy to have like a very basic way to push to other view controllers, but still keep it separate. There's probably not enough time to talk about the router model today, but I definitely recommend looking into it, because even if you don't use SwiftUI, it's a very, very good sort of model to actually architect your apps around. And the next one, obviously, I feel like this is so dirty because this is such an old school concept, but obviously if you have a view controller and you want to actually get callbacks from it externally, what can you do? Like delegates, blocks, you can do usually combine as well is a really good one now. There's like so many ways you can actually get state and events from a view controller now that I feel like using delegates is not the most popular, but at the same time, delegates are the tried and true method that Apple stands by. So I think in terms of a conference talk, this is what we should talk about. The great news is implementing a delegate's really easy because it's the same as a regular view controller. And I just want to point this out because I checked this manually to make sure it was possible. You can actually implement regular callback handlers and then attach them to buttons or whatever into a SwiftUI view. And then it might be a bit of daisy chaining, but you could then hook them straight up to the view controller and have the view controller, sorry, that's what I said, have the view controller forward along to a delegate, or you can even, because of the generic type of UI hosting controller, you can actually just say detail view controller dot root view dot on tapped handler, and it works like that as well. So you can just bypass and go straight there as well. And once that's done like that, you can then route it to any regular Cocoa methods. So that makes it really, really simple to hook it back to any non-SwiftUI code. Okay, I'm not going to talk about this too much because I think Peter Steinberger is about to talk about this in far more detail and far more eloquently than I could ever hope to. But one really cool thing is that you can actually wrap, I'm sure everyone knows about this, you can wrap UIKit code in SwiftUI. And I thought it was complicated code, but it's not. Like, this is the bare minimum you have to do. And it's literally make a struct with these two methods and you're done. Why you want to do this exactly is even if you don't use any of the SwiftUI's native controls, even the fact that you could use SwiftUI as a replacement for auto layout is still so much more valuable than doing auto layout yourself. So even if you create a view which was just a bunch of wrapped UI views, that itself still has a lot more control and speed and flexibility than doing it in auto layout. So even if you use SwiftUI to just display a bunch of UI views, I'd still say that's far more value than doing it with regular UIKit. And yeah, like I just said, like I was expecting it to be really hard, but it's not. If your UI view implements a delegate or a data source, there's a really cool mechanism called a coordinator where you can actually just make an NS object as a coordinator, and that becomes part of this struct, and that actually will handle callbacks, and you can then use that to update your SwiftUI state. But when I say you can use callbacks to update your SwiftUI state, there is actually a really big gotcha here. Something I really need to mention here because this got me stuck for a couple of days. Something you have to really remember is SwiftUI is value type because it's structs, but UIKit is reference type, meaning it uses objects. And these two don't play nicely with each other sometimes. One example I was doing with the drive mode was I needed to do a tutorial view. And so I was like, that's easy. I'll make a page view wrapped UI view controller. So the object was called page view, and the page view receives a bunch of SwiftUI views as its input. So basically, I give it an array of views, and I want the views to line up next to each other like it's a page view. So then that wraps a regular UI page view controller, and so that in itself, that page view will take those views, wrap each one in a UI hosted controller, and then put them into the page view controller. So that's easy so far. And then obviously there's a delegate event that will query for the next view controller, and will also update when the user swipes. So that's what I'm sorry. This is why I'm doing that motion. When the user swipes, it'll update the state saying the user has just updated to this index, this visible page index. And this was tricky because externally you could also set the index as a state property. But the problem is whenever you set both of these, SwiftUI being the way it works, SwiftUI will tear down its SwiftUI code and rebuild everything, but the UIKit code does not get torn down. It stays there. But basically what this meant was by updating the state, we were refreshing all the data, all the objects that were being hosted by the view controller. And so any sort of state checking where you could check what array index was this particular SwiftUI view in or whatever, that became invalidated. And that was a problem because suddenly, because you couldn't query for something existing in such a way, what actually ended up happening was it ended up creating a bunch of infinite loops. And once you actually realize what the problem is happening, when you realize what's going on, it becomes easy to fix. But it's just something to be aware of, that due to the nature of the fact that UIKit is state-based, the fact that it requires manual state updating, but SwiftUI doesn't. Basically, you can get into these weird situations where if you get UIKit to update the SwiftUI state, SwiftUI will then go back and update the UIKit state, and then you'll get into this infinite loop. And the way to fix that is really easy. All you have to do is make sure on your UIKit level, you compare your UIKit state to the current SwiftUI state, and you just exit out when the state is identical. And at that point, the infinite loop stopped. But that was probably the biggest thing I wanted to say today, because that is the main issue that I was having, but once I figured it out, it was really easy to solve. And then one final thing. In iComics, this is a really common pattern. It's a really common pattern everywhere. The ability to tap a button and have a pop-up show up. And you think it's really easy, but basically there's two ways you can go about solving this in UIKit land. The first one is you can use if you know exactly what the object is, if it's a view, you can actually anchor it to the view, and then the pop-up will appear over the view. Or if you just know the general position, you can give it a set of coordinates, and that works too. I know that Peter Steinberger actually tweeted this last night because he was trying to solve this problem on macOS, but macOS was a lot harder because that one actually required knowing exactly where the view was as the window resized. But thankfully in UIKit land, because Windows don't usually resize that much, it's a little bit easier. The one way I figured out how to do it really quick by checking in today was you can actually use, I was looking originally you can use Geometry Reader to try and work out the absolute position of elements, but one really cool thing I found in Stack Overflow is you can actually use gesture recognizers with a minimum distance of 0 for a drag to work out where the user released their finger and then get that position there. And from there you could then, why I'm saying this is from there you can pass that to a regular UIKit delegate, and then you can use that to present a regular pop-up, a regular pop-up view controller, or pass on to something else. But basically the important thing here is it's in certain cases where it's necessary to know where the position of a SwiftUI element is, you can then actually use this really not a great method, but it works to work out the position and then show it out. But obviously, like I just said, if the window size changes, then suddenly this becomes invalid, and you'd have to requery again. So in this case, I'd say whenever this happens, go back and think about your UX. In terms of iOS, if the window size changes, it wouldn't be terrible UX for the window to dismiss at the same time. So you could easily just think about how this would impact your user and mitigate it around like that. In any case, that's pretty much everything I have for today. Let's go back and talk about a few things. SwiftUI is amazing, even though it's a little bit brittle in cases, a little bit buggy in other cases. The fact you get so much stuff for free, and the fact that now it's mandatory for like iOS 14 widgets, I think everyone should be at least trying their hardest to use as much as they can, and then pull back on it. Obviously, be aware of its limitations. So when you run up against a wall, you can actually mitigate and find a more practical solution that goes back to UIKit level, but still doesn't let you have to like write off all the SwiftUI code that you wrote. I really believe that right now, if you utilize best of both worlds, if you can utilize the best of UIKit and the best of SwiftUI, you can create some fantastic experiences, and stable and relatively bug-free. I'll never say bug-free because that's impossible for my code. But you can create some really good software, and most importantly, you can do it extremely fast. And that's the coolest thing about this. The most important thing is have fun. I think one thing we have to remember is the tools don't really make the software. The software is basically what the best that you can do with what you have. The tools are you, and every single engineer is different. Every single engineer will come up with a different solution for a problem. And the great thing is we have these conferences to share what we've learned, because everyone will have solved a problem in a different way. And some ways might just be, there's no right or wrong, but some might be faster and some might be easier and some might be maybe more reliable and stable. But at the same time, everything's good and it's all fun. And that's pretty much everything I have to say. Thank you so much for listening. I hope you had a good time. I hope you learned something. and I hope you enjoy the rest of the conference.